Right, so this one, there's a fact over here, the distance travelled by car, so the time was 3 hours. We've got to, first of all, plot a graph of distance versus time graph. So, oh, a bit wonky. Obviously, if you're doing it, in a test, you would try to use a ruler, make it a little bit nicer. Right, so I'm going to start with my time. I've got 0 to 3, so I'm just going to go 1, 2, 3. It's in hours. Alright, distance is in kilometers and it goes up to 210. So maybe I'll just redraw this quickly. Alright, so I'll start with maybe 200 here. The half of that would be 100. Half of that would be 50. Half of these two would be 150. I'll just leave it at that and eyeball it. Right. So my first 0, 0. Next one would be 40 kilometers. So about there. And then that's when half an hour has passed. So 0.5 of an hour is half an hour, so that's like here. Next, 90 kilometers, so that's about here. And that was when 1 hour, so up here. Alright, and then 130 and 130 kilometers, I reckon that's probably about there. And then that's at 1.5, so like there. 170, just above here. And then that was when 2 hours, so here we go. 210, so about here. And then that's at 2.5 hours. There we go. And then at 3 hours, it was 2.10 again. So if I connect these dots, it would go like something like this and like that. Cool. Draw a line of best fit for the plot point, so that's what I did. Explain whether the motion of the car is constant over the 3 hours. Well, hopefully you can see that the motion of the car is not constant over the 5 hours because it is constant for when it is at 0 to here, so that's 2.5 hours. So 0 to 2.5 hours, you can see that there is a constant motion of speed, but this one, there is no motion there. So I would just write, have a read through your answers. The answers just say, this is illustrated by the straight line of best fit through the origin. The car remains stationary for the final half an hour of its motion, which I described over here. Now D, use your graph to determine the average speed of the car during the first 2.5 hours of its motion. Okay, so 2.5 hours is here. So we're only considering that much, that little slope here. So if we're trying to figure out the average speed, we've just got to figure out the gradient which is a speed, and that is just going to be the rise over run. Right, so how much did I rise? Well, it's not quite 200, remember it's 210. And then my run, so that was 2.5. So if I put that in the calculator, it should give me 84 kilometers per hour. Alright, now let's convert your answer to meters per second. So to convert kilometers per hour to meters per second, we'll hopefully understand all you have to do is divide by 3.6. So all you have to do is 84 divided by 3.6, which is 23 meters per second.